continue with question 2. Okay, we were handling rather complicated HCF and LCM questions. We have already learned how to find HCF or to find LCM using either the ladder method, otherwise prime factorization. Okay, so if you recall that. So looking at question 2, we're given that there is the number 9, 12, and k. The LCM of the numbers is actually 252. Okay, so if you set it up according to how you solve it for via prime factorization method, this will be how it looks like. Okay, for such questions, we can only do by prime factorization, cannot do by other methods. Okay, cannot do ladder method. Okay, it will not work out. So the question says that k is actually odd, so that we have to keep in mind. We want to find all the possible values of k. Right? So when we do our prime factorization method, we have to express our numbers in its prime factors form. So for the number 9, I think we don't have to do our ladder. We should know that 9 is equals to what? 3 squared. Okay? What about 12? Do we really need to do the ladder? What can I tell about 12? 12 is equals to what? 4 times 3 and 4 is 2 squared times 3. Okay? So some numbers we know it at the tip of our hands, so we can skip that. But then of course, if you want to do this as your habit, I'm not stopping you as well. Okay? Then for 252, that one may be slightly more challenging, so let's work it out. 252, we can divide by 2. 1, 2, 6, 63. Okay. We will have it like that. Hence 252 is 2 squared times 3 squared times 7. Okay. Any questions at this juncture? Alright, so now let's get to the main part of the work. Okay, LCM, if we recall, how do we get the LCM numbers over here? Okay, if I want to find an LCM. So now we have to work backwards. Okay, in order for me to get 2 squared, I had to look through everything over here. Okay, and I look for the largest one amongst the 3, then I take it out, right? Okay, for our lowest common multiple. Right? Now, there is this 2 squared here already. Okay, my 2 squared can be here, can also be here, but it's optional. Okay, now the question is, should I have 2 squared in my k? Why not? Okay, because k is odd, very good. Okay, so because k is actually odd, 2 squared can never be inside my k. Okay, so 2 squared we have clarified that already. Now let's look at 3 squared. Okay, 3 squared is found here already. That means that over here for k, I can have it, I also don't have it. Okay, so in fact, my options for out of the 3 squared is that I don't have 3 at all. Okay, or I can have just 1 3. Okay, otherwise, erase this part here. Or I can have 3 squared. Because if I don't have a 3 over here, down here has 3 squared already, this is already confirmed. Okay? So this 3 squared is a result of this 3 squared here. That's why it brought down here. Okay? But then, if I have just 3 to the power of 1, just 1 3, okay, it doesn't matter because I'm still going to take this one and place it here. I can also have 3 squared because if both have, I will still take 3 squared. But can I have 3 cubed? I cannot have 3 cubed because if down here 3 squared, 3 and 3 cubed, then down here I must have 3 cubed. You understand? Okay, so that's why 3 cubed cannot. The options are either don't have, 1 only, or 2 only. Okay, so that's for 3 squared. Okay, where will the 7 have to come from? 9 doesn't have a 7, 12 also doesn't have a 7. Okay, so that means the 7 must come from K in order for my LCM to have a 7. So all of it must have 7. So my 3 options, okay, my first question asked me to find all the possible values, okay. The possible values will have to be 7 only, or 3 times 7, or 3 squared times 7. So this is 21 and this is 63. Okay. Anyone doesn't get it, still lost. Sorry? Because no, down here you got 3 different answers. Yeah. So question say find all the possible values of K. You must give me all 3. You cannot just choose one of it. Okay, you must give me all 3. Anyone still not clear? Because we're going to increase that difficulty, yeah? Okay. So the goals there, you all good? No, still not clear. I can repeat one. You sure? Okay, yeah. So let's look at practice now 16. Okay, practice now 16. HCM is 245, LCM is 4410. Okay, they never tell you what are the numbers. They say that there are 2 numbers. Both numbers are in fact greater than HCF. We want to find out what are the 2 numbers. Okay, so we let the 2 numbers be called A and B. Okay, so we just let, we need to define what is A and B, so therefore we need such a statement, okay, to tell the reader what we're doing. So we have A and B. HCF, we know that it is 245, and LCM, we know that it is 4410. By my prime factorization method, I do my ladder and I will get the prime factors of 245 and 4410. So let me work that out. 45. So we will work it out, we will get this. Okay, so we need to set this up first before I can go and figure out what is HCF, what is A and B. So far? Okay, can I get started up? So let's look at the HCF first. Okay, HCF tells us, okay, what are the things that are confirmed going to be found inside my numbers A and B. Okay, because it is a factor both numbers must have. And then also because for highest common factor, remember the process, we're always looking at both of it must have, then we choose the lowest one. Okay, that's why we get here. Okay, so now looking at the 5, okay, what this tells us is that both A and B must have a single 5. To make things align, let me just write it like that. Okay, likewise for the 7 square, both of it, okay, will have 7 square. Okay. It is possible that the 5 has one more, okay, for one of them. So for example, okay, it is possible that maybe I have 5 square over here and 7 cube over here. Okay, so between 5 square and 5, I will still take out 1 5. Between 7 square and 7 cube, I will only take out 7 square. Because for highest common factor, we take out the lowest common one. Okay, a little bit of an irony, okay, because highest we think we want maximum, but then actually highest common factor, we look for the lowest possible one. Okay, whereas lowest common multiple, we seek the highest one as we saw over here. Okay, so it is possible 5 square 7 cube or other combination also can, but at the very least, we know that this must be there. Okay, there can be more, but there cannot be less. It cannot also be this one 5 square, this one 5 square. If both 5 square, then down here should have 5 square. Right? Okay, so therefore, minimum this will be the layout. Okay, so that is based on the information from highest common factor. Okay, now question actually says that both numbers are greater than HCF. So for A and B, right, I now have the HCF inside it already, okay, but A cannot be equals to this, B cannot be equals to this, because questions say greater. Okay, so now we have to look at the LCM. LCM has these numbers 2 and 3 square. 5 and 7 square already settled since we have it inside here already. It is this 2 and 3 square. It must have come from somewhere. Okay, so it must have come from the numbers A and B. Okay, so we are expecting some other number to multiply with this 5 times 7 square in order for my numbers A and B to be greater. Okay, so for this 2 and 3 square, right, if you recall our lowest common multiple, we take the highest of it all. So if down here don't have a 2 and down here has a 2, this 2 still comes here, right? Then for 3 square, okay, if this one doesn't have a 3 square and this one has a 3 square, then the 3 square comes here. But then is this the best way to place my 2 and 3 square? It isn't, right? Because, okay, then my number A itself will be 5 times 7 square only, and that is the HCF. So it doesn't fulfill this expectation from the question. So that means that one of these numbers, 2 or 3 square, okay, must actually be separated out. Okay, one of it has 3 square, the other one has 2. So that down here don't have 2, down here got a 2, I will have a 2 over here. Down here got 3 square, down here don't have 3 square, but my 3 square must still be in my LCM. You understand and following what I'm saying? Yeah? So that's why 2 and 3 square will be placed like that. Of course you can switch it around, that's perfectly fine. Okay? We clear? So therefore, I will conclude that A must be 3 square times 5 times 7 square. You press that into your calculator, we will get a, what is it? 2205. Okay, 2205. And B equals to 2 times 5 times 7 square, 490. Okay, great, thank you. Alright? Okay, in case one of you is wondering, okay, can I have 2 times 3 over here and just 1 3 over here? That means my 3 square, I separate them out. Since I got 2, but then both of them equally have 1. I cannot, huh? Why? Because if down here only 1 3 and down here 1 3, I should have taken out 1 3 over here only. I cannot achieve a 3 square. So the 3 square must be together. Okay? So this is not a possible option. Okay? So I'm trying to explain that not possible for one tree in A and B each. Otherwise, LCM will only have one tree. So that's why my tree must be kept together as 3 squared. Okay, so this one cannot have the tree. Questions? Are we good? Continue to look at question 2, alright? Question 2 says that they have given you 240 expressed as this, 252 expressed as this. Let me just write down the first question down. This one. So this question they gave you 240 and 252. It is product of prime factors already. Okay. We want to find the smallest non-zero whole number n for which 240n is a multiple of 252. A lot of words going on. Okay. I'm certain that most of you don't understand what the question is even talking about. Okay. So question asking you to find a number lah. Okay, non-zero means it cannot be zero. Okay, so you need to find a number that cannot be zero, must be a whole number, and it is the smallest. Okay, maybe you can ignore the idea of smallest first. Okay, let's just really understand this part. Okay, to know what we're talking about and what we're going to find. 240n, right? Okay, it is going to be a number. This actually means 240 times n. Okay? N is supposed to be a whole number, so 240 times something. It can be times 2, it can be times 3, it can be times 5, times 7, times 8 also can. Okay? We are going to find out what is this value of n. Okay? So because it is 240 times a number, what does it mean about this 240n? Because it can be times 2, times 3, times 4, from 240, right? That means that my 240n is a multiple of 240. Agree? Okay, 240n must be a multiple of 240 because we times 2, times 1, times 3, okay, and so on, right? But we don't know what is it that is going to times up. Okay, then the question also says that this number is going to be a multiple of 252. Okay, so eventually this 240n is a multiple of both 240 and 252. Okay, so that is what this statement is trying to say and trying to tell you. Okay, so I'm trying to break down the English for you, so that you can understand the question. Alright? Then, okay, since you're looking at a number that is a multiple of both, okay, we have already learned that concept through lowest common multiple. Okay, and we only have lowest common multiple that we can find. There's no such thing as highest common multiple. Highest common multiple cannot be exactly found out because multiples goes on forever, right? So we cannot find the highest one. Okay, so we can only find the lowest common multiple. So naturally, what the question is trying to ask you is to go and find out, okay, what is the lowest common multiple first. Okay, and this lowest common multiple is supposed to be 240n. Okay, so with this idea, we are looking at the numbers 240 and 252 such that the lowest common multiple is what we call 240n. Okay, and 240 and 252 already have it. Okay, expressed for us in prime factors already. Okay, so we want to know how does this 240n comes about. Okay, let's just ignore this part first. We go through our process to identify my lowest common multiple. Okay, so what is the first thing that comes in our lowest common multiple? First factor. What should I have? Let me choose someone. Emmanuel. Sorry, who is Emmanuel? Okay, yes, Emmanuel. And tell me, what do I think? 2 to the power of 4. Great. Okay. So 2 to the power of 4 and 2 square, we take 2 to the power of 4. Okay. What comes next? Let's choose another one. Brandon. Yes, Brandon. 3 to the power of 2. Yes, you are right. Okay, we take the largest one. Okay. Any more that we have to take? Alyssa. Who is Alyssa? Yes. 5 and 7. Wonderful. Okay, you are completely right. Okay, so LCM supposed to be 2 to the power of 4 times 3 squared times 5 times 7. Okay. But the question asking for value of n. The question is not asking you for LCM. Yes, Nati. Okay, so you went to calculate this one. Okay, yes, you can press this in the calculator and you will get 5,040. Okay, you get 5,040. Then, to find out what is n, you take 5,040 divided by 240. Okay, that is one way that you can do. Alright, so maybe let me write down that way first, what he is proposing. N equals 5,040 divided by 200. So we get 7. Okay? Other one, 21. Oh yeah, 21. Okay? Alternatively, you can see that 240 is being made up of 2 to the power of 4 times 3 times 5. Okay? Out of this, I can rewrite it as 2 to the power of 4 times 3 times 5 first. I have still one more 3 that is missing since it is supposed to be 3 squared, and then I have a 7. This is supposed to be my 240. This must be my n. So n is equals to 3 times 7, which is 21. Okay? Just suggesting this to you, but if you don't understand this one, it's fine. Okay? You can do this one perfectly okay. Questions? Here. Okay, so something similar to our part I. Okay, so let's break down this idea. Okay, maybe because you see the word factor, you naturally think highest common factor. Down here multiple, you think lowest common multiple, also can. But I want you to be able to grasp the language behind this as well. Okay, so question also asks for smallest non-zero whole number, so we're trying to find a whole number lah. Okay, for which 240 divided by m is a factor of 252. Let me give you the idea about this first. 240 over m. What does this actually mean? Okay, let's start with something simple. 12 over 3. 12 divided by 3 is equals to what? 4, right? What does this tell me about 3 and 4? 3 and 4 are factors of 12. Okay, so that means that if I have 240 over m, I will eventually get a certain number. This number m and this star over here, they must be factors of 240. Agree? Okay, agree? So this means that 240 over m as a number, it is going to be a factor of 240. The question also says that the entire number itself is a factor of 252. So this means that if I want to write a similar statement here, okay, I will say that 240 over m is a factor of both 240 and 252. Okay? Right? I erase this part, yeah? This is just for me to help you get the idea. Okay? But any questions? Shihan, is it? You sure you here? Do you see the copy? Okay, yeah. Okay. I mean, you need, you can tell me one. Okay, so I erase this up. Okay, so if I erase anything before you copy, you just scream and shout. Okay? If you want to scream, but don't be too scary lah, okay? Okay, so we understand that part of the statement already. For factors, I can only find highest common factor. Okay, no point for not meaningful to find lowest common factor in fact. Okay, so now we know that we're looking for highest common factor of the numbers 240 and 252. Okay, and the highest common factor is supposed to be 240 over m. Okay, when this number itself is at the highest, okay, it means that m must be the smallest. Because you take a number, you divide a very small number, you get a very big answer. Right or not? Okay? So for example, I got $240. If I only divide between Enqi and Trixie, right? Okay? If I divide between Enqi and Trixie, they each will get a lot of money. But if I have $240, I divide with the whole class over here, each of you going to get very little money. So that's why highest common factor 240 over m will help me to determine that m is going to be the smallest one. Okay? So now 240 and 252, using the question's information, I will have these numbers. And my highest common factor should be made out of what? Let me call it. Okay, let's see, as answering question already, so let me skip Enqi, sorry. Same rule. What should I get for my highest common factor? 2 squared, great. Okay, next one, what should I have? Joshua, what is the next factor in my highest common factor? 3, great. 1 3 only, huh? Joshua, 1 3 only, right? person. Let me just do a check. Elena, any more things to include into my highest common factor? Do I need my 5 and 7 inside it? No need. Great. Okay, very good. So highest common factor is only here. 5 and 7 we don't take because not in common at all. Okay. So therefore, highest common factor 4 times 3, that is 12. Okay. So we see that 240 over m is equals to 12. How do I find m? I will do the reverse. M must be 240 divided by 12. Okay? Just like our idea of 4 divided by 3 gives me 4. If I want to find this number here, I will take 12 divided by 4 to know that it is 3. So I now want to find the value of m here. Okay, I will take 240 divided by 12 and that will be equals to 20. Very good. Question 1. Okay, this is where we are given like a word problem. Okay, and we need to know what exactly is it we are trying to find. Because the question here isn't so straightforward anymore. You need to rely on your understanding of lowest common multiple or highest common factor to decide if you are going to find lowest common multiple or highest common factor. Okay, so let me help you understand this question. Okay, first of all, what does the question mean when we say 3 bells toll at regular intervals? What is tolling? Yeah, Xavier? Ringing. Okay, so that means 3 bells are ringing, and they ring at different timing. One rings at every 15 minutes, the other one 16 minutes, and the other one 36 minutes. Okay, so if I were to draw this out, okay, pardon for my very poor drawing. My drawing only limited to this for a bell. Okay. If you find drawings are good for you also, you can also draw it out. Okay. So 3 bells, 1, 2, 3. Okay. Don't judge my drawing lah. Okay. Hurt my feelings. Okay. One fat person in one day. How is it even fat person in one day? I don't know what I'm talking about. Okay, so it says that they toll together at 2 p.m. Let's maybe ignore that part first and try to get an idea. Because the question asks what time will they next toll together. How does this actually look like? Okay, maybe let's start with 2 p.m. now. Okay, so 2 p.m. they all ring together. Okay, so I just put a tick, indicate they ring together. What time does this bell ring next? 2:15, right? So 2:15 p.m. this bell will ring, the others will not ring. Okay? What time does the second bell ring? 2:16. Amazing. Okay? And then, what time will another bell ring again? 2:36. 2:30, right? Why? Because this bell will ring again. Okay? And then, 2:31. This bell will ring again. Right? 2:31, 2:32, or 2:32, sorry. Okay, 2:32, the 60-minute bell will ring again. Okay? Then, what time next bell ring? 2:36, right? Okay, then this bell will finally ring. Okay, the question is asking if this goes on, what time will all bells ring again? Okay, so this is what the question is trying to ask. Okay, should we be thinking about multiples or should we be thinking about factors? We should be thinking about multiples. Why? Because look at the situation over here. It started off ring once, then it ring a second time, then after a third time. So it is going for in multiples of 15 minutes, and then for this one multiples of 16, and the last one multiples of 36. It is continuously going on, having the idea of multiples. Okay, that's why we are going to look for LCM. Okay, so this is what the question needs us to go and find. Okay, 15, 16, and 36. Express it in its product of prime factors. 15 is fairly simple. What do I get? 3 times 5, right? What about 16? 2 to the power of 4. Okay. And then 36, what will you get? 2 squared times 3 squared. Okay. If you can't do this fast enough, don't worry. You can go and do your ladder. Okay. I'm trying to speed things up a little bit. Okay. So therefore, I skip that step. Okay. We get 15, 16, 36 like that. Then now we want to find LCM. Okay. What and how do we find LCM? Actually, can you give me the whole thing of LCM? Actually? Yeah. So what do I get from LCM? 2 to the power 4 times 3 squared times 5, and that value is, or can someone help? What's the value? 720. Very good. But is this the answer that we want? No, because the question asks for the time. Okay? 720 is what units actually? Minutes. Okay? Because these are all in minutes. So 720 minutes. Okay? We need to convert our minutes into hours by dividing by 60, and we get 12 hours. Okay, so 12 hours later, what time will it be? Therefore, the bells will toll together again at 2 a.m. Okay? We're done with this chapter, okay? So, question 2, 3 pieces of rope, 140, 160, and 210 cm. Different lengths. So, if I want to draw it out, I'll just use a rectangle to represent it. Okay? Perhaps do it something like that. Okay? We want to cut it into equal smaller pieces. So, use a scissors, we cut. Okay, maybe we cut it like that. So every part is going to be equal. exactly is that activity? Okay. Question asks, what is the greatest possible length of each of the smallest pieces, such that there is no leftover at all? So out of this 140 cm, we are cutting out a part of it. Okay, cutting out a part is like dividing. And when we're looking at dividing, we're looking at factors, right? Just like if I have $140, okay, I want to divide equally to everyone, I divide, right? And that is a factor, okay? Alright, so therefore, what we're looking for is to find a factor, and we're looking for greatest possible length, so highest common factor. Okay? Questions? So this one, understand that it's looking for factor. So not as complicated as this one where I draw the bells. Okay? Now, we have the number 140, 168 and 210. We need to put it into its product of prime factors. So we do our ladder. So let me do my ladder here. 270, 5, 5, 7, 7, 1. Okay, we will have this for our numbers. What will our highest common factor be? Okay, look us up. What is our lowest? Our highest common factor? 2. How many? How many 2s? Just 1. Okay. What's next? 7. Okay. Anything more? No more. Quick. So 2 square, 2 cube, 2. We take out only 1, 2. 7s, we take out 7. 3 we don't take because down here missing. 5 also missing over here. Okay. So our highest common factor is 14. That means the greatest possible length is 14 cm. The last part, part 2. Okay, how many smaller pieces of rope can she cut all together? So each part is now going to be 14 cm. To know how many parts come out from 140, we will take 140, divide by 14. Okay? And then we do the same for every single row. That's 168 divided by 14 and 210 divided by 14. Okay? You can write your working in this manner, you don't need to do it part by part. Okay, so we need to level up in the majority of our answers. Okay, so number of smaller pieces. Please write your statement as well. If you don't write statement, nobody knows what you're trying to calculate. So we need to develop this habit now. Then press the entire thing into your calculator and you can get 37 as the answer. Okay. Questions? Okay. If no questions, okay, for homework, okay, for the end of this chapter, exercise 1C. So I adjusted the homework question for the other class as well. Question 2, 3F. Hang on. Okay, no need 3F. 5F. 7E. 11, 13, 14, 20 and 21.